monochloroacetic acid, dichloroacetic acid, or trichloroacetic acid. Which one is stronger and why? This is today's lesson. In this lesson, we are going to arrange the acids according to their acidity strength. So, let's begin. Let's try to discuss the strength of acids one by one. First of all, monochloroacetic acid. This is structural formula of monochloroacetic acid, which ionizes to produce proton and monochloroacetate ion. Here, this oxygen gets partially negatively charged, this carbon gets partially positively charged, because this oxygen is a higher electronegative atom than carbon. Oxygen's electronegativity is 3.5, carbon's electronegativity is 2.5. That is why this carbon-oxygen bond gets polarized, and because of this positive charge, this oxygen-hydrogen bond suffers a heterolytic fission, and as a result, this hydrogen gets freed as proton. Here, this positive charge over carbonyl carbon increases because of the presence of chlorine here. Here, chlorine acts as negative inductive affecting atom. That is why acidity of chloroacetic acid increases than simply acetic acid. Because of the presence of negative inductive affecting atom, chloroacetic acid, that is monochloroacetic acid, acts as stronger acid than plain acetic acid or ethanoic acid. Let's see another acid, that is dichloroacetic acid. Carbon, hydrogen, here chlorine, here another chlorine. Structure formula of dichloroacetic acid. Similarly, it produces proton, that is, this hydrogen gets freed as proton and dichloroacetate ion is formed. Here, this carbon gets partially positively charged, oxygen gets partially negatively charged. Because of this positive charge, this bond, oxygen-hydrogen bond, undergoes a heterolytic fission, and this hydrogen gets freed as proton. Here, positive charge increases more than monochloroacetic acid, because here two atoms are present. Those are negative inductive affecting atom. That is why density of positive charge of carbonyl carbon increases and this hydrogen gets freed as proton easily. Here it is produced easily, but here it is produced more easily because of the presence of two negative inductive affecting atoms present. Last one is trichloroacetic acid. This is structure formula of trichloroacetic acid. Here this hydrogen gets freed as proton and trichloroacetate ion is formed. In this case, that means for trichloroacetic acid, which contains 3 atoms of chlorine, those are negative inductive affecting atoms. Here this carbon gets partially positively charged, it gets partially negatively charged. Because of the presence of 3 atoms present, that is negative inductive affecting atom present here, so in this case positivity over carbonyl carbon increases the most. That is why this bond undergoes heterolytic fission more easily, and this hydrogen is freed as proton more easily than the dichloroacetic acid. That is, here it is produced most easily because of the presence of 3 negative inductive affecting atoms present here that increase positive charge over carbonyl carbon. That is why this bond undergoes, that is oxygen hydrogen bond undergoes heterolytic fission more easily. This hydrogen gets freed as proton more easily than the second acetic acid and than the first acetic acid, that is then dichloroacetic acid and then monochloroacetic acid. So here proton is produced from this hydrogen most easily, this is more easily, and it is produced easily because of the presence of only 1 atom, that is minus inductive affecting atom present here. Here 2 atoms present, 2 minus inductive affecting atom present. Here 3 minus inductive affecting atoms present. That is why here this hydrogen gets freed as proton easily. In this case this hydrogen gets freed as proton more easily, and in this case this hydrogen gets freed as proton most easily. So we can say that trichloroacetic acid is the strongest acid, dichloroacetic acid is moderately stronger acid, and monochloroacetic acid is simply stronger acid. So the reason is presence of negative inductive affecting atom. Here 3 atoms present, here 2 atoms present, and in case of monochloroacetic acid only 1 atom present. That is why trichloroacetic acid is the strongest acid, dichloroacetic acid is moderately stronger acid, and monochloroacetic acid is simply stronger acid. Again, if we see stability of these acetate ions, this is monochloroacetate ion. In this case it acts as electron withdrawing atom. Here electron withdrawing atom, this is 2 atoms, here 3 atoms, electron withdrawing atoms. So in this case only 1 atom present, electron withdrawing atom, that disperses this negative charge. That is, this negative charge is dispersed by only 1 atom, negative inductive affecting atom. Here 2 negative inductive affecting atoms present. That is why these negative charge dispersed in a greater amount. That is why dichloroacetate ion becomes more stable than monochloroacetate ion. Similarly, here 3 atoms present, negative inductive affecting atoms. That is why these negative charge dispersed on a large scale, and for this reason this ion becomes most stable than this ion and then this ion. So it becomes most stable. This is more stable and this is simply stable. So from the stability of the acetate ions, trichloroacetic acid is strongest acid, then dichloroacetic acid, and after that monochloroacetic acid. Again, pK value of this acid, monochloroacetic acid, pK value of monochloroacetic acid is 2.87, pK value of dichloroacetic acid is 1.35, and pK value of trichloroacetic acid is 0.77. So from the values of pK, we can say that trichloroacetic acid is strongest acid, because we know the lower the pK value, the acid will be stronger. As pK value of trichloroacetic acid is the lowest, so it will be strongest acid. Then dichloroacetic acid is moderately strong acid, and after that monochloroacetic acid is simply stronger acid. So from the tendency to produce proton, trichloroacetic acid is strongest acid, and then dichloroacetic acid, and after that monochloroacetic acid. And for the stability of chloroacetate ion, trichloroacetate ion is more stable after releasing proton, and lastly monochloroacetate ion. From the stability of chloroacetate ion, trichloroacetic acid is the strongest acid, and lastly pK values, pK value of trichloroacetic acid is the lowest, so it will be the strongest acid, and after that dichloroacetic acid, and lastly monochloroacetic acid. So simply we can write trichloroacetic acid, that is strongest acid, then dichloroacetic acid, and lastly monochloroacetic acid. This is the arrangement of chloroacetic acids. This is all about strength of chloroacetic acids. No more today. Thank you very much.